We're looking for students who are self-motivated, who also have the curiosity to answer questions.
What are the new emerging contaminants that are out there? We're now being able to see that there are these kind of new emerging contaminants that may affect humans if you were to drink it over your lifetime. So civil engineers, environmental engineers, always evaluating our treatment system to make sure that we are able to remove some of these new emerging contaminants.
There are lots of emerging technologies out there: pyrolysis, gasification, anaerobic digestion. How can we make them work for solid waste? Do they work for solid waste?
We instrument vehicles with portable instruments, and then we measure the real world activity, energy use, and emissions. So we think of the road as our laboratory. We've been able to quantify the contribution of acceleration to emissions compared to idling and cruising at constant speed. And we find that most of the emissions take place because of acceleration. And so if we can manage traffic control in a smart way, we can reduce emissions without asking people to change how much they drive, just how they drive.
One of the areas that I've been very involved in over the past few years is looking at indoor fuel use in developing countries. This fuel use indoors emits these black carbon soot particles, which end up having a very, very strong warming effect on the climate.
Another topic that we try to understand is ocean energy and what opportunities are there along our coastline.
The coast is such an important part of North Carolina, and we have an excellent affiliation with the University of North Carolina Coastal Studies Institute in Manio, where we can perform collaborative research, obtain real-time field data from the coast, and analyze it back in Raleigh.
During storms, as we're trying to make predictions about storm surge and overland flooding, it's nice to be a couple hours away so that the electricity stays on and we can run our computer models.
One thing that's unique about our department is our computing and systems group. To manage civil engineering infrastructure systems, we need computing capabilities and we need new models. There are faculty in our department who are researching software engineering, building new models, and high-performance computing.
So this clean energy standard basically, if I want to do uncertainty analysis and I want to test a set of assumptions, I can actually do now 88 model runs in parallel. And this is a really big deal because particularly in my field, we've often been hampered by our ability to do the uncertainty analysis. We spend a lot of time building big, complicated models, then we generally run them under a few scenarios. So with computing infrastructure like this that we have available at NC State, we can actually do uncertainty analysis in a way that hasn't been done before.
The idea of our work is to use climate information to make differences in water management.
What do you think a water manager is going to do to make sure we have water resources in the future if the reservoir is going to be depleted by population growth? We need a better understanding of what social scientists already know. So they have a whole fields of understanding how people are using water or using other technologies, but we don't usually plan our infrastructure around that. So this research is building computational models where we can plug in those social science theories, models, data, and improve our understanding of how that will affect our infrastructure. So really we're not social scientists, we're engineers, but we're building tools so that we can create a bridge between engineering and social science.
Come join us to develop sustainable infrastructure for society.